Hello everyone, my name is Smriti Singh and in this video I am going to explain about Aashto classification system on behalf of MIT Academy of Engineering Pune, and I am from School of Mechanical and Civil Engineering and my roll number is 104. So let's get started. So first of all we need to understand what is Aashto classification system. So Aashto stands for American Association of State Highway and Transportation Officials. And this classification system is used mostly by state and country highway departments. And this classification was developed in 1929 as the Public Road Administration Classification System. So, what are the requirements for this classification? So, basically, we need two main things, that is particle size analysis and plasticity characteristics of a soil, of that particular soil that we want to classify. So, by analyzing the particle size, we get to know two things, that is plasticity index and liquid limit. So, first we need to understand these two terms, what is meant by plasticity index and liquid limit. So, in simple words, liquid limit means water content where soil passes from plastic state to liquid state. And what is plastic index? It is defined as difference in liquid limit and plastic limits, or LL minus PL. Here, LL stands for liquid limit and PL stands for plastic limit. So, plastic limit is the water content where soil starts exhibiting plastic behavior. Okay, so that was about particle size analysis, and as soon as we get this value of this we get the values of this thing. One examines the columns and ascertains whether they satisfy the limiting values in that column or not. So as you can see, there are many columns here, and if my column satisfied that particular conditions of the given soil, then that soil is classified in that column, and if not, we will move further. And one thing you need to take in notice, that you always need to move forward in left to right direction. Never move in right to left direction, or else your classification will be wrong. Uh, so, what are the procedures for classification? So, according to this, there are seven major groups, and that is from A1 to A7. As you can see here, A1, A2, A1, A2, A3, A4, A5, A6, A7. And A1 and A7 are further divided into two groups. So as you can see, A1 is divided into A1A and A1B, and A7 is divided into A7-5 and A7-6. And similarly, A2 is further divided into four groups, that is A24, A25, A26 and A27. And there are two major classification. First is granular materials, that is 35% or less of the total sample if passes your sieve number 200, then this will be categorized in this type of material. And if your total sample passing sieve number 200 is more than 35%, then it is classified in silt clay material. Okay, so let's move forward. Now, what is criteria of classification system? So there are two main criteria, that is grain size and plasticity. So first, let's come to grain size. A soil is classified as gravel on the basis of fraction passing the 75 mm sieve and the amount retained on the number 10 sieve. And then a soil is classified as sand on the basis of the fraction passing the number 10 US sieve and retained on number 200 US sieve. And the soil is classified as silt and clay on the basis of the fraction passing the number 200 US sieve. Now come to next thing, plasticity. So first we need to understand what is meant by plasticity. So plasticity of a soil is its ability to undergo deformation without cracking or fracturing. So let's move forward. The term silt is applied when the fine fractions of the soil have a plasticity index of 10 or less. So we need to move to our table. Okay. So the term salinity is applied when the fine fractions of the soil have a plasticity index of term of 10 or less. So here you can see in the silty soil that 10 max is written. It means that the plastic index maximum that we can apply to this silty soil is 10, not more than that. For example, if our soil is having a plasticity index of 12 or 13, we can't classify that in this silty soil category. Now let's move on to what was written further to that. And the term clay is applied when the fine fractions have a plasticity index of 11 or more. So here in our clay soil, you can see it is written that plasticity index 11 minimum. So it means that our soil should have at least a plasticity index of 11 or more than that. For example, if my soil is having a plasticity index of 16, then we can classify it in the category of clay soil, otherwise no. Now let's move further. Okay, and then next we have these two equations. So let us try to understand what this means. So I would like to give an example. Let us suppose that we have a soil and the percent of soil passing sieve number 200 is 41%, liquid limit is 50%, and plastic index is 15%. So if we come to this table again, what I have told, soil having percent of soil passing sieve 200 is 41%. So minimum 41%. So we can see from this clay soil table that our soil maybe A6 or comes under A7 category. Then the liquid limit is 50%. So in A6, the max liquid limit is 40. So if we have more than liquid limit than 40, that is 50 is obviously more than 40. So we can't classify our soil in this A6 category. Hence we will go to that A7 category. Okay. So keep it in mind that A7 also has two categories, that is A7 pi and A7 6. And okay, so plasticity index is 15%. Okay, so it also satisfies this 11 minimum plasticity index criteria. So as you can see, my soil satisfy all these conditions. But what about later thing? My soil will come in A7 pi or A7 6. How will we classify that? So these two equations will help us classify that whether that comes in A7 pi or A7 6. So we will be evaluating the value of liquid limit minus 30. So as I told, my liquid limit was 50. So 50 minus 30 is 20 and my plasticity index was 15. So 15 is obviously less than 20. That was 20 was my value of liquid limit minus 30. So therefore my soil will be classified as A75 in A75 category. And if suppose my plasticity index is for example 50 and my value of liquid limit minus 30 is 10, then that soil will be classified in A76 category. And this one note that I have already mentioned, that one must apply the test data from left to right by process of elimination. The first group from the left into which the test data fit is the correct classification. As I have already told in the starting of this video. Okay, so this was all about the criteria of classification system. Now, group index, one of the most important thing. So first of all, let us understand what is meant by group index. So in order to evaluate the quality of soil as a highway subgrade material, one must also incorporate a number called the group index with the groups and subgroups of the soil. So this index is written in parentheses after the group or subgroup designation, and So for example, if my soil comes under category A3 and it has a group index of 13, so we will be writing it as A3 and 13 will be written in parentheses like this. And we can calculate group index by using this equation. And here F200 denotes percent, stands for percentage passing through the sieve number 200, and LL represent liquid limit, PI represent plastic index, and as we have already discussed, PI stands for plasticity index and is given by liquid limit minus plastic limit. And yeah, then other important things is rules for determining the group index. So if our equation 1 yields a negative value for group index, it is taken as 0. Like for example, if my group index is coming minus 2.5, minus 3, then I will simply take it as 0. Then the second rule is the group index calculated from equation 1 is rounded off to the nearest whole number. That is, for example, if my group index is coming as 3.4, 2.8, then I will round it to the nearest whole number. That is, if it is 3.4, I will be rounding it to 3. And if my group index is 3.5, I will be rounding it to 4. Then rule number 3, there is no upper limit for the group index. And then rule number 4, the group index of soils belonging to groups A1A, A1B, A24, A25 and A3 is always 0. And then rule number 5, when calculating the group index for soils that belong to groups A26 and A27, use the partial group index for plasticity index, or GI is equal to 0.01 into percent of soil passing through sieve number 200 minus 15 into plasticity index minus 10. So you always need to keep this in mind that if your soil comes under these two category, never use this normal equation. You need to this one equation, which is basically you as you can see it is more simple than this one. This will make your work easy. Then okay, so that was all about my explanation. To make you understand more perfectly, I would like to take a question. So a sample of soil was tested in lab and the following observations were recorded. And the liquid limit of my soil is 45%, plastic limit is 16%, percent passing US sieve number 10 is 91.5%, percent of soil passing US sieve number 40 is 80%, and the percent passing US sieve number 200 is 60%. So first we need to calculate the plasticity index, as you need to keep it in mind that we need plasticity index and not the plastic limit. So as we have discussed, plasticity index is liquid limit minus plastic limit. So when you will put the values in, you will get the value of plasticity index as 45 minus 16 is equal to 29%. Okay. Then let us see the amount of soil passing through sieve number 200. That is 60%. So here we need to move on to our table. Okay. Yeah. So here you can see that if the 35% or less of total sample passing sieve number 200, then it will be granular material. So, but our soil passing is 60% through the sieve number 200, so it is obviously not this one. It is this silty clay material. But now see, here our soil can be A4, A5. Our soil could belong to A4, A5, A6 or A7, any of these. Because you can see that the percent of soil passing sieve number 200 is 36% minimum in all these soil categories A4, A5, A6, A7. So we also need to evaluate other things, that is liquid limit and plasticity index. So let's move on to the liquid limit. Okay, so here the two things are clear, that my soil will either come in the silty soil or clay soil. So now come on to our liquid limit. So here our liquid limit is 45%. Now moving on to table. 45% is the liquid index, but for silty soil we have 41% minimum liquid limit for uh, so silty soil has two categories, A4 and A5. So A4 has 40% minimum, 40% maximum liquid limit, and our liquid limit is 45. So it is obviously not this one, A4, so it is eliminated. Then come to soil category A5, 41% minimum liquid limit, and our liquid limit is 45%. So it can be this A5, and it can be and A6, it has 40% max liquid limit, so it is obviously not A6. And then A7, 41% minimum liquid limit. So it can be, we have two choices and we have eliminated two soils. So we have two choices, it's either A5 or A7 soil. Okay, so now let's move on to plasticity index. So our plasticity index was 29%. Okay. So moving on to table. So our soil can either be A5 or A7. But here in A5, as you can see, the maximum plasticity index can be 10%, not more than that. But what is our plasticity index? It is 29%. So A5 is eliminated. And now what is remaining? A7. So it is surely confirmed that our soil is A7, but keep in mind that A7 also has two categories, A7-5 and A7-6. So how now we need to classify whether it is this one or this A7-6. So as we have discussed the two equations here, we will be using this. Okay. So uh, our liquid limit is 45%. So what will be liquid limit minus 30? It will be 45 minus 30 is equal to 15%. And we have already calculated plasticity index 29%. So you can simply see that the plasticity index is more than liquid limit minus 30 value, that is 29 is more than 15%. Hence, we can conclude that our soil type is clay and comes under A7-5. Let's move on to table. So, our soil is clay and comes under A7-5. Now, we should not forget this about group index, which we need to write in parentheses. So, moving further, we will calculate our group index, which is our step 3. So we will be putting the value of percent of soil passing through sieve number 200, which is 60%, liquid limit 45%, and plasticity index 29%. So after calculating this, we will be getting group index is equal to 14.1%. But according to our rules that we have discussed here, according to this rule 2, the group index calculated is rounded off to the nearest whole number. So our nearest whole number is 14. So our group index is 14. Okay, so soil is classified as A7614 in parenthesis. So this was all about Aashto classification system. I hope you understood this topic well. Thank you for watching.